Question 8 was asking us to differentiate the function in two different ways. One as a product, using the product rule, and the other one to multiply, expand first before differentiating. So the first function prime, 4 times 1 over 2 the square root of x, 3 prime is 0, times the second function, plus the first function times the second function prime, bring down 3x squared. 4 divided by 2 is 2. X to the third power minus power 1/2. The square root of x is x to power 1/2. So 3 minus 1/2. And then I distributed 3 to 4, so I got 12. X to the second power plus power 1/2, because we multiply. When we multiply exponential notations, we copy the base, add the exponents, and then 3x squared times 3, and I have the third term. Since this is power 6 minus 1, so 5/2, and this power is also 5/2, 2x to 5/2 plus 12x to 5/2 is 14x to 5/2, and I copied. So this is the final form of the derivative of this function using the product rule. Now, multiplying first, x to the third gets multiplied by, gets distributed by to 4 the square root of x, which means 4x to 1/2 plus 3. X, the square root of x is x to 1/2, multiplied by x to the third is 1/2 plus 3, and then 3 times x cubed. 2 times 3 plus 1 is 7/2. So when I differentiate this, I bring down 7/2. 4 times 7/2 is 14. I subtract 1 from the power and I get power 5/2. I bring down 3. I subtract 1 from the power and I get 9x squared. Therefore, these two are identical. 14x to 5/2 plus 9x squared, same thing. Same type of problem. We're asked to use the product rule. The first function prime is 4 multiplied by the second plus the first function multiplied by the second one prime, 4x plus 3. And then I distribute it, combine like terms, and I get this. If we need to multiply first, then 4x to 2x squared is this, 4x to 3x is this, 4x to 5 is 20x, then negative 3 distributed to 2x squared, negative 6x, and then negative 9x, and then negative 15. Combining like terms, first term is 8x cubed. These two will give us a 6. These two will give us an 11x minus 15, and these two are identical. Next, we're asked to differentiate. They're not enforcing any method, so of course I distributed. T cannot be 0. It's in the denominator. So t times this is 3t to the 6th. T times this is negative t cubed. This times that is negative 15. T to the 5th divided by t is t to the 4th. And when I multiply negative t squared by negative 5 over t, I get positive. 1t goes away, so I have only 5t. Very easy now to differentiate this. I bring 6 down, I get 18. Subtract 1 from the power. Bring 3 down, subtract 1 from the power. Bring 4 down, negative 60, subtract 1 from the power, and 5t prime is 5. I have to rearrange it correctly in descending order. T to the 5th, t to the 3rd, t squared, and 5. Next problem, we have to differentiate a quotient that has only one number, no variable at the top. Of course, I change it into t plus 2 to negative 1. When I differentiate, I bring down negative 1, subtract 1 from the power, and then I go back and it's done. Here I cannot do that trick. Why? Because the numerator has the variable. So the top prime is 6x plus 2 times the denominator minus the top times the denominator prime, which is 2x. I cannot leave it like this. I have to distribute, combine like terms, and get into a simplified form. So x squared times this, or this, 6x times this, 6x times 1, 2 times x squared, 2 times 2. 2x times 3x squared with minus in front, 2x times 2x with minus in front. These two go away. The degree is negative. The degree is 2, so I have negative 4 plus 2, and then 6x and plus 2. I will factor a negative 2 from all these three terms, negative in front of the fraction line on the same line with the equal symbol, negative and the fraction line. So then I have x squared minus 3x minus 1. By mistake, when I wrote it, I jumped to 62 and then 60. I'm sorry, my apologies. So this is another function. It has a constant. I will put the constant in front because it only has one term at the top, and the constant can wait patiently. The top function prime is 1 times the denominator minus the top times the denominator prime, which is 2t. So 2t squared minus 4t squared will be negative 2t squared plus 9. Of course, oops, with 500 in front. Okay, so I factor negative 1. So negative 500 2t squared minus 9, and this is the final form. We're asked to find the population after 12, not sure I didn't, 12 years, sorry, right here. Okay, so I plugged it in. P is in thousands, so that's why the answer is 20,202 people. Then we're asked to determine the rate of change in 12 years, after 12 years. So all I have to do is just take this expression and plug in 12. Use the calculator. Do not forget to put parentheses for the top here. It's okay. But if you don't put parentheses in the denominator or parentheses here in the numerator as well as the denominator, you're not going to get this answer. Which means that the rate of change after 12 years is a negative rate of change. It decreases by 1,581 people, 1,581 people per year. 60, we are given the cost and the revenue. We have to determine the profit function, which is this. And then we are asked to find the rate of change of the average profit. So we have to find the function first. The average profit is P of x divided by x. So 75x to 0.8 divided by x, copy the base, subtract the exponents. 0.8 divided by, or subtract power 1. I get this. Negative 18x to 0.7 divided by x, I get negative 18. 0.7 minus 1 will be negative 0.3. And then negative 900 divided by x is negative 900x to negative 1. This is what I want to differentiate, and here it is. Bring down negative 0.2, multiply by 75, I get this. Subtract 1 from the power. Bring down negative 0.3, multiply by this, 5.4, subtract 1 from the power. Negative 0.3 minus 1 is negative 1.3. Bring down the power, changes into positive, subtract 1 from the power. At this point, I'm asked to evaluate the function when x is 20. Skateboards, of course, but not here. We don't have to write the measurement unit here, but we absolutely have to at the end. So I just plugged in this expression everywhere, 20, put in the calculator, and I got a positive 1.95. So the rate of change of the average profit when we manufacture 20, the average profit increases by $1.95 per skateboard. We're given a function. Of course, I'm not going to differentiate this. I change it into x to the 5th plus 6x to 1/3. I bring down 1/3, subtract 1 from the power, times the inner function prime, 5x to the 4th plus 6. And then I rewrote it because that's a negative exponent, so I put it back. The same thing here. I bring down to 204, multiplied by the function raised to 204 minus 1, times the inner function prime, 4 times 7, 28x cubed, 6 times 3, 18x squared, and minus 1. Thank you.